evening. In this programme, we're going to look at the autumn sky, go to a star party, and talk to an eminent cosmologist. But first of all, our news notes. On September the 7th, we had a partial eclipse of the moon.
Yes, it was rather low in the sky, but we did get some nice photos. This one's from Jamie Cooper, and although it's just a partial, it's good training for our next total eclipse in March.
Also from the moon, the end of Smart 1, that very successful probe that crashed down in the Lake of Excellence, and the flash was actually observed at the end of a very good mission.
Yes.
And from Mars. Remember the Mars face? Well, it's been photographed again by Mars Express, and nothing like a face at all, I'm afraid.
No, but it does illustrate the fantastic quality of the Mars Express images, and we can really see the planet in great detail. Now let's go to the outer solar system.
Oh, yes.
Now last month we talked about the end of Pluto's reign as a planet. Now the object that caused all that fuss, 2003 UB313, which had been called Xena, has now been officially named. And the name they've chosen is wonderful. It's Eris, the Greek goddess of discord, thanks to all the chaos and argument that it produced. Now let's go back to Saturn, where the Cassini mission is still sending back spectacular results.
And a new ring.
That's right, associated with the satellites Janus and
Epimetheus.
That's right. And it just shows that the gravity of those bodies manipulates the ring particles into the complicated shapes we've seen. And one very nice last shot, the Earth as seen from Saturn, that pale blue dot.
And now a discovery that may be very significant indeed. A Type 1a supernova is brighter than it should be.
That's right, these are Type 1a supernovae with material flowing onto the surface of a white dwarf. When it reaches a critical mass, about 1.4 times the solar mass, it literally explodes, blowing itself to bits. And we thought we knew that those explosions were always the same brightness, because they always reach the same mass when the star explodes.
Therefore, we use them as standard candles and measure the distances.
Absolutely. Now, this recent Type 1a supernova is nothing like that. It must have had much more mass than that critical 1.4 solar mass limit. Now, that doesn't make any sense. It's maybe something to do with the star rotating. But the crucial point is, if this can happen once, then it can happen in other supernovae as well, and maybe they're not the standard candles we came to expect. Now in this case, it had other weird things wrong with it. It took longer to fade, for example, so we could identify it as something odd, but it does throw a spanner in the works of our most distant indicators of distance.
The last supernova seen in our galaxy was that of 1604. I think we're now overdue for another.
Yes, but not too close, please, Patrick, if that's all right.
Chris, thank you very much. And now on to our main programme. In autumn, the main constellation is Pegasus, the flying horse, now high in the sky, and the four main stars make up a square. Now look at the two right-hand stars, Beta and Alpha, and follow a line down almost to the horizon, and there you will find a bright star, and that's Fomalhaut in the southern fish, one of our nearer neighbours, and very interesting, but almost certainly it does have planets going around it. Now back to the square, the top left-hand star, Alpha's, being transferred to the next-door constellation of Andromeda. And Andromeda is a line of stars leading away from the square. And above the second star, somewhere above it, you'll find a misty patch. And that is M31, the great Andromeda galaxy, a spiral more than 2 million light-years away, and the faintest object clearly seen with the naked eye. And in the evening sky, we don't yet have Orion, but we can soon see the Pleiades, that lovely cluster which heralds the entrance of Orion and his retinue. Well, at least there's plenty to see in the autumn sky. One very pleasant function is a star party, and the Autumn Equinox Party was held at Kelling Heath in Norfolk, and Lucie Green went there.
This is my first time at a star party, and I'm really looking forward to having a look through some of these telescopes here tonight. Now these guys have been here all week and the weather has been fantastic, so fingers crossed that it holds out tonight. The Autumn Equinox Star Party has been running for 12 years. It started out as a jamboree for the astronomers of Norfolk, but soon attracted enthusiasts from all over Britain. It outgrew its original site at Thetford and has been based at the rural campsite of Kelling Heath for the past 3 years. The weather at previous star parties has been mixed, and today is no exception. It's been raining solidly for 7 hours, with some of the astronomers struggling to keep their telescopes and equipment dry.
When you're booking it a year in advance, you can't predict the weather. Well, it's hard a week in advance in this country, let alone a year. And certainly if there's just one particular night, it can be a problem. But if you come here for about a week, which a lot of die-hard astronomers do, you normally get 4 or 5 nights out of the week. But hopefully it will clear out tonight and we will get some clear skies.
And how many people are you expecting to turn up?
There will be about 300 or 400 astronomers camped on the field during the main weekend. And on the Saturday, because it's open to day visitors, we should have about another 100. So we'll probably have about 400 to 500 people here.
Now, that's a huge number, actually. Does that make it the biggest event of this kind in Britain?
It is, in terms of an amateur-run star party event, yes, and it has been for quite a few years.
It must give you quite a buzz, actually. Is that why you like to organise these events?
I do. I enjoy sort of promoting astronomy. I enjoy letting people look through telescopes and point the night sky out. And I still get a buzz now when somebody looks at Saturn for the first time and goes, wow. And they all do. They all go, wow, when they see it for the first time. And I think it's great.
There is a fantastic range of telescopes here at the party. The large Dobsonians are the most eye-catching. Described as light buckets, they are ideal for picking out the more elusive deep sky objects. Other telescopes include the classic Newtonian, bought for a couple of £100, or this beauty, which would set you back at least 10,000. Whatever they own, the Star Party is a place for astronomers to share their passion and enthusiasm for the night sky. Are you set up and ready to observe?
We're getting there.
Yeah, we're just about set up. I mean, the scope's level, pointing north. So yeah, if we can get rid of the clouds, then yeah, hopefully we should be able to do something tonight.
This is a telescope I've just built myself. It's a 14-inch Dobsonian, and this is about the second time I've used it in anger.
Yeah.
So,
will you be taking any pictures?
no, I've got imaging equipment. But I've decided to just try and do some visual, and I've got a few pencils to do some drawing as well. So I just want to limit myself because it's too easy to do too many things here and look at other people's telescopes, and then I'm looking at my own. And whatever you're doing, you feel like you should be doing something else.
We've only been in the hobby 2 years, and this is the first time we've come to something like this, and it's amazing. People are so friendly walking by, and it's like you've known them all your life. And we don't have the smallest scopes here, I hope, but that doesn't really matter. We're going to have some fun, and that's what it's all about. So
this is a Pentax 75mm short focus refractor. Gives quite a wide field of view of the sky. The camera I've been using is this beastie.
Oh wow.
Now this actually contains a 35mm sized chip. With this camera fixed in the back of here, I get a huge field of view.
Part of the success of the Autumn Equinox Star Party is the ideal combination of darker skies but warm nights. The summer triangle is still visible, but so too are the early morning views of the winter constellations. If the weather is right, it's a magical time. It's 10 o'clock and unbelievably the clouds from earlier have completely disappeared, and it also seems that the rain may have cleared the atmosphere, so this has turned out to be just the kind of night that the astronomers have been hoping for. All the campsite lights are now off, and anybody shining a torch is encouraged to switch it off. We're using special cameras to film in the dark, and in the pitch black it's a strange feeling to hear hundreds of astronomers chatting, sharing their experiences and enjoying the sight of far-off galaxies and nebulae. So are these skies some of the best in England?
They are. You can go to other places in Cornwall, in Wales or in Scotland to find dark skies, but they're quite hard to get to. They have industrial type pollutants as well, of course, and so given the conditions we've got here, statistically we're more likely to have a range of clear dark skies in Norfolk, and so it does make a great place for a star party.
I mean, the skies really are beautiful here, but is there a more serious note? Why do we really need dark skies?
Well, astronomy is all about looking at things in the night sky, of course, and looking at things in the universe. Now, you can look at planets, and you can look at all the faint fuzzy things, the galaxies. Now, of course, if you've got light shining up into the sky, that causes the sky to brighten, and that means that the fainter stuff you're looking for become less visible.
And then lastly, how do you rate the conditions here tonight?
I think we've been really lucky, actually. Over the last week we've had some cracking clear skies, but they have been plagued a little bit by a haziness in the sky, sort of a milky feeling to it. And we had a good downpour of rain earlier on today, and that's cleared the atmosphere a treat. And looking at the sky now, we've got the Milky Way stretching above our heads. Looks really stunning. It's probably sort of 7 or 8 out of 10, I would say, being a local chap and getting a bit spoiled by the skies out this way. But yeah, it's a really good night, nice and stable, and we're seeing some fantastic views.
You've got to see this, eh?
During the Star Party, we like to use the opportunity to show people who might have smaller scopes at home the objects that they wish they could see more detail in. So they turn up, they see a nice big scope like this, and they can go to the objects they see as small, fuzzy objects, and just see them as this beautiful explosion of stars or swirling arms in a galaxy. So that's the most satisfying part for me, is to have people turn up and be able to see a view they wouldn't necessarily be able to see before.
Can you give me a guided tour of some of these objects?
I'd love to, yeah. You've got Hercules over there with M13, the Great Globular Cluster of Hercules. Beautiful, beautiful little explosion of stars. And in a scope like this, instead of a fuzzy knot, you can see right into the core and see huge chains of stars arcing out, almost like little spider's legs. It's a fantastic sight. And then maybe sort of move up to M57, which is a planetary nebula where stars exploded and puffed off all its outer layers, and it looks like a little donut in space.
OK, so can we take a look at one of them?
Yes, certainly, certainly. Which one would you like?
Ooh, the star cluster sounded good.
The star cluster, yep, no problem at all. So that'll be M13 over here. And we'll look over at Hercules. Okay. And you've got the keystone shape of Hercules.
Yeah.
You've got the two stars on the right, and about a third of the way down from the top is where M13 is. So we'll just find that. And it should be a bit low down, I'm afraid. And there we go. Right.
Gosh,
would you like to have
found
a look
that
through
really
there?
quickly.
Go on.
OK. Oh, fantastic. That's an amazing star cluster. Now, are there any other objects that you can show me?
Absolutely, yes. I'd love to show you some galaxies if I can.
OK. So do we need to move the scope for that?
Yes, we'd like to swing over to here. We've got to M33, which is a galaxy in Triangulum. If you look at Triangulum, very long, thin triangle, sort of like a wedge of pie or a slice of cheese or something. If you look at the end star of the point, then move your way up to the next brightest star above it. That's the bottom of the chain of stars that the Andromeda Galaxy is on. And if you go a third of the way up and just a little bit out to the right, then you should look through and see it.
Oh, that's amazing. There's so much structure you can see there. Oh, that's beautiful.
As we're looking overhead at the Milky Way, straight away I can see Cygnus, a fairly bright and obvious constellation, and within that constellation is an object that we call the Veil Nebula. The Veil Nebula is a remnant of a supernova, and with a filter you can see it as a wispy trail of sort of nebulosity and gas, and it's quite a phenomenal sight to see the intricate detail, especially when you think it's a remnant of a star that exploded, thousands of years ago. And then there are two parts to it. The fainter part of the veil, which some people call the witch's broom, because it's got a thin part above it and a sort of a wispy part below it. But then quite a distance away, it's about 2 degrees away, is the slightly larger and brighter part, which people call the bride's head. I think it was Herschel that termed that term because it looked like this wispy veil.
That's a nice description. Yeah. Well, it's now 4 o'clock in the morning, but the diehards are still out here observing. I've had a great time this evening enjoying some of the sights in the autumn sky, and it really has been a fantastic introduction to my first star party.
Star parties are great fun. I wish I'd been fit enough to go. And now to something quite different. Professor Jim Gunn is a very eminent cosmologist. He was over here for a visit, and in my garden, Chris talked to him.
Well, you've had a long and illustrious career in cosmology, but how did the universe look when you began?
Rather different from the way it looks today. At that time, there were lots and lots of theoretical ideas and almost no data to pin them down. The theorists had very simple models of the universe, not because there was any evidence that the universe was simple, but just because the simple models were the only ones they could calculate. And it has fortunately turned out in the intervening years that those simple models seem to describe the universe really exquisitely well. I think very, very much better than they had any right to believe at
surprisingly
the time.
Well.
Yes, surprisingly well. But the last 50 years have really turned up enormously wonderful things. We know that there was definitely a Big Bang from the cosmic microwave background radiation. Very shortly after I got my PhD, very distant quasars were discovered, and so we saw things for the first time that were some substantial fraction of the age of the universe.
And the important thing is that the universe looked different back then.
Yes, that became clear quite soon, although it was very controversial for a long time because many people didn't believe that the quasars were that far away. Once you accepted that, it was clear that when the universe was a third its present size, it was also a very different place and full of very different things. So the subject has matured enormously, but I like to tell my students that one of the tenets of the scientific method is that we must be able to do repeatable experiments. But there's only one universe. And so when we apply some principle that we think explains something, there is really no way to properly test that. And we can be led terribly astray, and I think people have been led terribly astray in the past. The subject is very full of human hubris, because what we're trying to do is take the physics that we know in the laboratory and experiments that we do and apply that to try to explain the whole universe. You have to put that in the perspective of today, in which 4% of this universe we live in is made of something that we even begin to understand, and the other 30% of it is dark matter, whose nature we don't know, and 70% of it is dark energy, about which we know even less. So a little healthy skepticism is certainly in order in this business.
Well, let's go back and see how we've got to this ridiculous theory where we're a tiny proportion of the universe. You mentioned the cosmic microwave background. Now, why is that so important?
It's very important because it's the earliest thing in the universe that we see. The radiation we see in the microwave background came to us when the universe was 500,000 years old, roughly. It's now 13.7 billion, and we know that number with some certainty now. So it is our only window, really, into what the universe looked like at that epoch and before. The other thing, and the main reason today why it's so enormously important, is that even though you look everywhere in the sky and it's virtually the same, it's not exactly the same. And the brightness of this background varies by a few parts in 100,000, and it is those very variations that gravity has been able to take hold of and make the galaxies and the clusters and the stars that we see today. Without them, we wouldn't exist. And with them, we can in principle make the universe that we see today. But one of the great industries in this field has, of course, been attempting to take those initial conditions that we see in the microwave background and to predict how gravity makes that evolve into the universe we see today. And of course, those have been enormously successful, but only with the addition of these extra things that we don't understand very well.
We have this picture of the universe with two mysterious components, so let's take them one at a time. Why do we think there's dark matter?
Oh, I think actually we've known that there was dark matter for a very long time. In order to understand the coma cluster, it was necessary that there was a lot more matter there than one could see in the galaxies. Much later, it was discovered that there was much more matter in galaxies, in the outer parts of galaxies, than could be explained in this way. And then I think people really began to take seriously that this dark stuff was not ordinary matter made of atoms that we know about, but some probably new elementary particle that had not been seen before.
But then we have the serious problem to work on. This is dark energy.
Dark energy. It could be some kind of funny scalar field. It could be the fact that maybe our ideas about gravitation are wrong, and it's not a cosmological constant, but gravity changes character at large distances. These things are all incredibly difficult to test. Human ingenuity is very, very difficult to predict, of course, so one can't say. But I would be very surprised if very much progress is made on this problem in the next several decades, at least. And the idea may well come not from observations, but from theory, because it's very, very difficult to see, even if one observed some details of this that said it wasn't constant, it was changing. I don't think we would know how to interpret them at the present time.
Well, we'll talk to you in a few decades' time and we can see how we're getting on.
Well, I hope you can. Yes, good.
Thank you very much.
Thank you very much.
Professor Jim Gunn, a very welcome guest, and his view of the universe. Don't forget, it's newsletter time. If you want your newsletter, send your stamped addressed envelope to Newsletter 103, The Sky at Night, BBC Birmingham, B1 1RF. And when I come back next month, we're going to go all the way to Venus. Good night.
An extended version of The Sky at Night is on Tuesday at 8:30 over on BBC 4.